Okay, now, hi guys. We will continue with our next lesson, which is we will go into the next kind of function, which is a piecewise defined function. Piecewise defined function, or you can think of this function as some sort of a partition function. Partition, meaning that you partition the domain accordingly. For certain domain, it will take certain value. That's mean. Okay. For instance, one of the most basic piecewise defined function is basically the absolute value function, which is fx equals to modulus x. Okay, this modulus function is quite interesting because if you partition this into two, okay, for positive value of domain x including 0, okay, the image will be positive. It will take x value, okay, and for x is less than 0, okay, it will take minus x value. This is an absolute value function. Okay, so in order to illustrate this concept, it's easy. If you do not know how to do it, that is very simple. Okay, for instance, you can always substitute value. For instance, you substitute f1 equals to modulus 1, okay, which is modulus 1. Modulus always naturalize all these different value to become positive. At the end, it should be positive. Meaning modulus 1 is 1. Okay, so meaning that whenever you x equals to 1, you got 1. Okay, okay, and if you got f negative 1, it will become modulus negative 1. It will naturalize all this negative value to become positive. At the end, it will become positive. So negative 1, you will get 1. Similarly, whenever you got negative 2, it will become 2, and so on. Of course, the positive one becomes it. And then if you try to illustrate this function, okay, this will be something like this. It will be straight line of a V shape. And straight line, use your ruler. Okay, use ruler, don't use freehand like me. Okay, I will deduct your mark in exam if you use freehand for straight line. Okay, and then it will be V-shaped function. Okay, we call this as a V-shaped function. You can adjust this. Okay, this is one of the basic piecewise defined function, which is a modulus function, because in this range we got a positive gradient. Okay, the graph increasing or something, positive gradient, and in this range we got negative gradient. Okay, so that is one of the piecewise defined function. And the domain will always cover all real number, meaning that you can see the domain always cover all real number. So you can see from minus infinity to infinity, of course, real number. And the range, okay, all this modulus function will always neutralize all negative value to positive. So meaning that we will just have a positive value only, starting from 0 and then go up. Okay, meaning that it will become from 0 until infinity. Okay, that is one of the piecewise defined function, modulus function. Okay, let's consider another example of piecewise defined function. Okay, this is another example, okay, whereby it consists of three different partitions. When x is less than 0, you got negative x. When x is in between 0 and 1, you got quadratic x squared. And when x is larger than 1, it will take a constant value 1. Okay, try to graph this on this axis. Okay, we will discuss more on Friday's lecture about this one, but you need to try first. Okay, of course I will ask you in class later on, so try to graph it first. Okay, I will do another example. This is another example on the piecewise defined function, okay, whereby we partition into two domain. Okay, the first one is basically x plus 1 when x is between 0 and 2, not inclusive 2, and x is larger or equals to 2, okay, when it will take the y value 0.5x. Okay, now let's graph, okay, let's graph the first one first, okay, meaning that when x okay, in between 0 and 2, meaning that this one, whenever to graph a straight line, this is just a straight line graph, power 1 power 1, okay, you just need 2 points for a straight line. So when x equals to 0, okay, we will get, whenever you substitute 0, you will get 1 only, so meaning that we got this one. Okay, you're fine with that. And then when x, okay, it cannot include 2, okay, but of course we can try to substitute 2 first. Okay, 2 plus 1 is just 3. Okay, so whenever x equals to 2, you will get 3 is somewhere around here. Okay, so but it's not including 3, so we make okay, circle will not fill. And of course it is a straight line. Use your ruler and use round one time. Okay, you got this straight line curve. Okay, now you take x equals to 2 again, because it's including 2 here, and substitute inside. Okay, 0.5 times 2 is just 1. Okay, and then okay, now you take, if you do not know how to do, okay, you can always substitute value, because straight line you just need at least 2 points to get a straight line. So you just substitute value. Maybe I will just substitute value x equals to 4, because x is larger or equals to 2. Substitute inside, you got 2, so x equals to 4, and you got it here. Okay, of course you can always sum, and then of course it will continue on and on. Okay, meaning that I will put this kind of arrow, meaning that to tell you it's continue on. Use your ruler. Okay, and this is okay, y equals to 0.5x, and this is y equals to x plus 1 graph. Okay, okay, notice that the point, okay, the point 2, 1 is included. Okay, 2, 1 is included here, but not the point here. 2, 3 is excluded in this line, because it well defined at 2, 1. Okay, there is 3 example of piecewise defined function. Okay, okay, in another kind of example of a function is what we call as a greatest integer function, or the integer floor function. Okay, integer floor function, and it's always denoted by this symbol you got here. Okay, something like this. Sorry, not this one, not this one, this one. So something like this. Oh, okay, floor function is floor. Okay, floor. Okay, floor. Okay, this is the floor. Okay, okay, now floor function is basically to tell that we always take the minimum value. For instance, if you got 2.4, okay, and you want to know the floor function, floor or lantai, so the minimum as opposed to ceiling function. Ceiling is the maximum, floor is the minimum. Ingat, floor minimum, okay, as opposed to ceiling, which is to tell you is a maximum. Okay, floor, meaning that we are considering integer. Okay, so 2.4 is basically in between 2 to 3. Okay, the minimum is 2 and the maximum is 3. Okay, so 2.4, if we take floor, you will get 2, because it's the minimum. This will got 2, and this is the integer 1, 2. 1.9 is basically 1 and 2, so you will take minimum 1. Okay, 0.2 is between 0 and 1. Okay, you will take 0, and this is 0. Okay, negative 0.3 is basically between negative 1 and 0. Okay, minimum. So negative 1, of course. Okay, negative 1.2 is between negative 2 and negative 1, so you take negative 2. Negative 2, of course, you take negative 2. So if you try to draw this kind of function, and this is some sort of interval that it is defined, we always take the minimum one, okay, for this kind of function, and you can draw this as a one straight line. Okay, this is what we call as a greatest integer function, or in computer science we call as a floor function, integer floor function, minimum function. Okay, as opposed to this one, whereby we call this as least integer function, or we call it as ceiling function. Remember, okay, ceiling, okay, we are interested with the maximum, okay, the upper value, okay, and floor, we are interested with the minimum. Okay, for instance, in the case, okay, and and the notation is floor is the notation is this one, okay, and ceiling, the notation is this one, meaning that you got the square at the up. Okay, that is how we indicate ceiling and floor. For instance, in the case of 2.4, okay, we want a ceiling, the maximum integer. So 2.4 is between 2 and 3. So it will be the maximum. So we take 3. Okay, so and all this, if we are taking the supremum value, or okay, so you can plot this as a straight line, okay, for the integer ceiling function. Okay, and of course, okay, this ceiling function is very useful. The application is basically in computer science, okay, in computer science, okay, whereby if you consider different kind of mathematical packages like MATLAB, Maple, and all that, they have an built-in function. They got this seal, okay, in computer science to indicate ceiling function, and they got this floor to indicate the floor function in MATLAB. You can check this, it online, got documentation online, okay, MATLAB function. Okay, and normally like all these computer scientists try to program, for instance, all this automated machine that you might go to Queens Bay or something, and all these are just an automated machine to pay for your parking. So normally they use all these ceiling function. Normally it will charge you the cost of parking X in hour at the parking lot, charge to like the according to the ceiling function. For instance, if you are parking maybe about like 2 hour and 30 minutes, 2.5 hours, and they will put some sort of ceiling function, either to charge you either maybe 1 ringgit or 2 ringgit. They will take the biggest value or the biggest amount. They will charge you 2 ringgit, the maximum amount. And this is the application of the ceiling function, where you need to program it inside the computer, and it can adjust whatever it is that you want to adjust accordingly, and it will take the maximum or the minimum one, either ceiling or floor. Okay, with that, I think that's enough for our today's lesson. Okay, so please do some of the homework that I leave you with, and I see you next week on Monday. Bye.